Now let's discuss EOI. EOI is end of interrupt. It is a command sent by microprocessor to 8259. Now when it's sent, now when your microprocessor actually executing your 8086 interrupt service routine ISR, right? At that time, when that ISR gets over, it send the signal to your 8259, right? Now why you need to send it? Because once the interrupt service routine gets over, the pin is actually one when that interrupt service routine is executed in that in service register, right, of 8259. So now you need to tell your 8259 that this interrupt is over. If you don't tell your 8259 that interrupt service is already over and it is already served, it still shows that it is in the service and no other interrupt will get the service. So to let your 8259 know that your current interrupt which was served is now over, to tell that you need to send some command, and that command is end of interrupt command. I hope you get it. Yeah. So let's discuss how 8259 works. So step 1, any interrupt occurs, so the corresponding bit in your interrupt request register will become 1. Then the priority reservoir will check interrupt request register how many the interrupt has occurred, which one is having higher priority. Then it checks that interrupt mask register, is it mask or not. If it is not mask and if it is a higher priority, then it will check the in request in service register, right? If it is already in service, it is more priority than the service register, like current interrupt, or it is having the less priority, and accordingly it will decide that I need to send it to the microprocessor or not. If it is having the highest priority and it is a valid interrupt, it will send to microprocessor through what? Through INTR pin. If it is not, it can be invalid because it is masked, or it can put in a pending list if its priority is lesser, right? Suppose it is valid and will inform our microprocessors, right, through INTR pin. So what microprocessor will do? Microprocessor will finish its current instruction, then it will send the signal on INTA bar. You remember that microprocessor will send two INTA bar signals. So initially it will send the first INTA bar signal, so that is the confirmation that I am going to handle this interrupt. So 8259 will update its in request register, so it will make the pin 1 that my interrupt is gonna get served. It will make the 0 in the interrupt request register because now it is going to get served, and calculate the vector address, right? During this time your microprocessor will send the second INTA bar signal, right? On the second INTA bar signal, your 8259 will has already calculated the vector address, and it will send it to microprocessor using data bus. So now your microprocessor is having the vector address of the interrupt that is being served. So now microprocessor will find out the IVT table, its actual address. It will run your interrupt service routine, execute that interrupt service routine, and at the end of that interrupt service routine, it will send the EOI command, end of interrupt command, so that your 8259 will update its in service register, right, and make it 0. So now it is again open for all for serving new interrupts. So this is the crux of how your 8259 works. I hope this is clear. Thank you.